Hello everyone, today I want to explain about my recent experiment. Actually, this is the continuation of my last experiment about Fourier neural operator where I tried to predict the turbulence movement from the simple fluid. I think it's just a toy test dataset. Now I want to step up my game, so here I'm using the real atmospheric dataset. It's a global model. It is RPG dataset, so they are basically from France. It's based on Toulouse model. And to open this dataset, I forgot. I will show you how it looks like, how it file looks like. Actually, the dataset that I'm using in here is not just this. The total of the dataset that I will use to train my model, all of them is inside my hard disk. This is just for the test dataset. It's because I don't put it in my PC because it's too heavy. It's make my storage, it's just run as my storage, so I don't put it in my PC. Here, basically, the file name is look gibberish, I think, but the order of this dataset is like this. So you see here A, Y, N, G, A until here A, Y, N, G, Q. So the order from A to Q, and the time step of this dataset is per 3 hours. So to open this dataset, we are using XRI, and it's not just XRI because we need the engine to open this dataset. In this case, it's a GF script. Here in this script we extract the level in 850 millibar, and the parameters that we will use in this video is U, V, R, and T. The resolution of this dataset is 0.5 degree. The latitude must be the same, right? Yeah, basically the same. Oh yeah, if you confuse why I say that the resolution is 0.5, because we just need to check the difference between the nearest index in the array. So this is 40 and 39.5. Their difference is 0.5, so the resolution is 0.5. Actually, at first I plan to convert those scripts data to the NPZ. That's why here I using a CFS compressor. But when I try to open them using a dataset, in the dataset from the PyTorch class, I stumble upon an error, and it said, and it looks like the compressed dataset or NPZ data can be opened in parallel. And you know that in the dataset in the dataset class in PyTorch, to make things faster, they open our data in parallel. But we can do that in NPZ. That's why I forgot where I put that code where I convert this NPZ data to the NPY. Of course, because I'm using NPY, then the size will become bigger than NPZ, but it's okay, I still can contain it in my PC, so it's not a problem. I think this is where I put the part where I convert the NPZ data to the And now this is the class of the dataset for the RPG. Here here for the init, I open the NPY dataset. So because this is the NPY, then every parameter will have their own files like this. The U component in ucomponent.npy, etc. And after that, I also try to find the mean and standard deviation of the dataset. It's for the process of the normalization of the data in later step. And also this is the output from the query of this dataset. Here at the end, we will outputting the input torch and the label torch. And for the model, actually it's basically the same with my last experiment. In here, I just change the data that I've trained in my model here, because the process of the training of the data, the process of the training of my model will be taking a long time. So that's why I do it in offline, and I will just show you the result of the plot. Yeah, this is the part where I forgot to mention before. So because my limited resource in this experiment, I tried to make a random crop. So in here, the input of the model will be 64 times 64 times 64 field of the UV, relative humidity, and temperature. And actually, because we do random cropping, then in my opinion, it will bring us a more general result or more general pattern in the model. So the model basically will learn better because of our treatment here, this random crop. Okay, back to the result. Here, as you can see here, for the R8, the first time step is okay, right? It's similar, but for the next time step, it's getting hazy like this. It looks like the neural operator can predict the local structure well. See? But as you can see here, the composition for the high relative humidity and low relative humidity, it's quite well. They predict quite well for the composition, but not for the local structure, like in the ground truth on the bottom in here. And this is for the temperature. As you can see, it's good to predict the global movement or the global composition or the global structure of the ground truth. But when it comes to the local structure like this, like in here, in Sulawesi, there is anomaly temperature, like its temperature is quite high if we compare with its surrounding. But because the neural operator here can catch the local structure, then it can predict it. Now let's see how it go in wind. As you can see here, it's quite good to predict the wind movement. And that is happen when I'm just using the very same setting with my last experiment, using Toy Test dataset, 16 as the filter and 20 as the width context. And in this experiment, I also do something. So in here, I increase the filter to 32 to hope that the neural operator can catch more detail about the local structure, and also I also increase the width of the context, and this is the result. Here, this is the result for the LH. I think there is no significant change in the quality of the prediction. And here for the wind, I think there's yeah, I think it worked. As you can see here, it gets the movement of the cyclonic like things in here better than our previous neural operator that have a lower context and lower filter, right? Because we only have 64 times 64 for the training dataset, for the width and height of the image of the training dataset, then the limit of the filter will be 32. But if we using, for example, 128 times 128, then we can move from 32 to 64 as the limit of the filter. Yeah, but as you know, I have a limited resource for my experiment, so that's why I don't do that. And now I also using this model, this model that use a better filter and better context. I use that for the to predict, to simulate the Senyar cyclone that is happen in Sumatra, and this is the result. The area near Silicon will have a higher relative humidity. It's obvious, but as you can see here, the neural operator can predict them well. So yeah, let it be. Oh, about temperature, there's no significant change in the ground truth data. So yeah, fair enough. And here for the wind, I think this is the most important parameters for the cyclonic, for the for this cyclone. Yeah, the cyclone is happen in Sumatra in here. But as you can see, in the neural operator in here, they can catch the pattern of the cyclone in their prediction. I think that's all. Thank you. Bye.